So last time we basically discussed the key flows, call flows of session management. Before that, we discussed the mobility management, and this time we're just going to have a little bit of in-depth review of those call flows. Like if we capture a trace, then what sort of information we're going to see over there and how to correlate it with the call flows that we have already discussed. Okay, so let me just done. Okay, so the key signaling process. So first we will start with SGSN. When I talk about SGSN, I mean the 2G and 3G, specifically the 3G flows. 2G are very similar to 3G flows, so we will concentrate on the call flows of 3G. Okay, so these are some reference of 3GPP documentation. If you want an more elaborative description of these call flows and other, because I'm covering the basic call flows. So if you think that you need an insight into other call flow, the secondary and the tertiary call flow, so you can refer to this 3GPP documentation, and based on this, you can have a better insight on how this is going to happen. Okay. So the attach procedure, as we discussed during attach procedure, there is location registration is done. The SGSN get the subscription data from HLR, and it can be done on GB interface or IU interface. The communication with HLR is on GR interface. I hope my screen is visible to everyone. Okay, that's great. Okay, so moving forward, this is a little bit of overview of the attach procedure that we discussed. So we have an attach request coming to SGSN. If it is via PTMZ, then it will collaborate with all SGSN to get the IMSI information. And if it does not get the IMSI information, it will ask MS-ISDN for IMSI. After IMSI is received, it will perform the authentication and the IMEI check. And if an old PDP existed, this is something that happens if you're already attached. We can skip this part. We will update the location update to HLR, informing the SGSN information, and HLR is going to respond back with the subscription data, and the update location is going to be completed. If it is a combined attach, then you have update location to the MSC as well. Okay, so that is going to be done. And once that is done, then you have the update location answer, and you have attach accept and attach complete message. So we will have a little bit of insight into how I mean what messages and what are the key information to look into the trace. A trace has so many information because different vendors have different proprietary information and all that. So there are only a few key things that are required to be known that you need to note as a PS core engineer, which is helpful in troubleshooting, which is helpful in identifying any issues when you capture a trace, because usually you capture a trace when there is an issue. Okay, so the main steps: MS initiates the attach request, SGSN operates the identity, authentication, security mode, and common ID. This I'll explain it. What is the security mode and what is common ID procedure? Then the location update, attach, accept, PTMZ allocation, and then you have your final. Okay, what is A and B for? A and B. The A and B is basically when you are already, I mean, if your session was already there on old SGSN. For example, you were connected to an old SGSN, then you turned off your data and you moved to a new location, and that new location was being served by the new SGSN. So your PDP already existed between the old SGSN and the GGSN. In that case, when you get your identification message and SGSN respond, and the new SGSN knew that the old SGSN, that this user was previously attached to OLS, so it will ask the GGSN to delete the PDP request, the old PDP request, which was between the old SGSN and the GGSN. So this is part A. And again, the GG, and then based on this, the old SGSN will remove the PDP request from itself as well and inform the PGSN, and it will respond back to it as well. So this is just the case where you are already attached to an old SGSN. Okay, so this is a typical attach procedure trace. So you will see an attach request. You will see an identity request, which is to get the IMSI from the MSISDN. Then you will see this map open request, service request, and a certain this is because if you remember in over the GR interface, the protocol that is running is map. So it is map communication with the HLR to get the authentication sets. Then you have the authentication procedure with the MSISDN, which is basically to get the authentication done. The MSISDN then responds back with the authentication. Then SGSN initiate the security mode procedure. The security mode procedure, like I mentioned, is a procedure between SGSN and RNC, and that is to basically negotiate the encryption and integrity procedure and the algorithm. If you remember, in 3G we had quintet. We have 5 keys that are sent by HLR. So one of this is the encryption algorithm, and one is the integrity algorithm. So these algorithm needs to be informed to the RNC as well, because once the data comes from RNC, it needs to be encrypted. So this is what is done via security mode command and its response. And then there is the common ID. The common ID procedure is sent to the is used to send the IMSI to the RNC and to ensure that there is paging coordination done. So via security mode command, it will send the IMSI of the MSISDN. Then there is your coordination with the HLR for location update. You send a location update, and HLR will send the APN information and the subscription information to. This is again over the map. Then SGSN will, based on this, the SGSN will send an attach accept message, and it will send a PTMZ in its message. Okay, so this is your attach accept message, and then there is the attach complete message with the MSID informing that okay, it has accepted this attach. And then there is IU signaling release procedure. Release procedure, if you remember, I told you that since there are limited number of bearers available in the RNC, so if you are not using any data services for like 44 seconds, this is configurable in the RNC end. So your bearer gets released. So this is the IU release, the IU signaling connection release procedure is this, that after you have been attached, but you have been and you're not using, so your signaling procedure, your IU bearer or your IU signaling connection is released, and then it is reestablished once you try to activate a PDP request. Okay, so attach. So now we will check into, we will have a little bit elaborate look on each of these messages. So first is there your attach request, which is sent by MSID to the SGSN. After being powered on, the MSA will initiate attach request. It will determine its attach type based on the network mode included in the system postcard message. So whether it's a GPRS attach, which says combined attach and all that. So this is something that the MSISDN decides, and it is also configurable in your handset as well. You can send a combined location update. You can send a GPRS attach to ensure that which sort of attach do you require. And the main thing that the MSISDN carries in this is either the PTMZ or the IMSI. If it was previously attached, it is going to be PTMZ. If it's a new subscriber, it will send an IMSI. So what is it going to do is that if you see, this is a basic attach request. So here is the type of the attach, GPRS attach. Okay. Like I mentioned before, there are so much information. Even I don't know all of the information, but we will just cover the significant information that needs to be checked when you're capturing a trace. So it's the attach type is going to be an attached request. It's a GPRS attach. Okay. Next is whether you are what sort of identifier you are sending, whether it's a TIMZ or PTMZ. So it identified that it is a PTMZ, and this is the PTMZ basically which has been sent. Then you send your location information, the old routing area information. So it's the LAC and your rack information along with the PLMN ID. Like I told you that it's PLMN ID 4100, I mean MNC MCC. plus the location area code plus the routing area code that makes up your routing area ID. Okay, radio access capabilities, signature, and all that. This is not significant to anything that we have studied previously. Okay, so these are the main thing. The type, your whether it's IMSI and TIMSI, and whether it's your location information. This way we can capture it as SGSN. Yes, obviously, this is what you will capture at SGSN. If you enable a user trace on your IMSI, based on your IMSI, you can enable a trace on this. What I can do is that if you have time, I will show you how to capture a trace as well. Okay. Or Asan, you can coordinate with me one-to-one, and then I'll show you how to capture a trace. Okay. So after that, obviously, once you get the task request, the next is the authentication procedure. The authentication, it includes two steps. The SGSN gets the authentication start from HLR and HLR, and 5 groups of quintets are sent by the map message twice. Okay, so you will see in messages that there are two times the SGSN sends the map message, and it will mention that how many authentication sets it requires. So 5 authentication sets are sent, and each and every time, and there are a set of authentication set. I mean, it is not going to be the same authentication set which will be used. So there are a couple of authentication sets that SGSN can request. This is configurable in SGSN, and the maximum value is 5. So you can request 5 different sets of authentication information. So total 25 parameters in a group of 5. Okay, so maximum 5. It is configurable, and SGSN keeps all those 5 sets. During one communication, it will use one set. During the next communication, maybe it will use the other set, and all that. And once all have been utilized, then maybe in your following attached request, it will ask HLR for more authentication sets. Okay, and then SGSN will proceed with authentication with the MSISDN. Authentication request messages sent, and the authentication response messages sent by the MSISDN. So how it works is like this: that once you're sending to the HLR, you are going to send an authentication information argument, SAI, send authentication information, and you will send the IMSI of the number that needs to be authenticated. Based on this, and you will also request the number of vectors that are required. So you are requesting 5 vectors. 5 quintets are required. Okay, so in response to that, it will share 5 different authentication sets to you. Okay, so this is the response of the HLR. HLR will send you the quintuplet set. So it will send random number, the expected response, the ciphering key, the integrity key, and the authentication. So okay, so this is one set. So it will send 5 different sets, or according to the sets that have been requested. Okay, so this is how you identify that, okay, the HLR is sending a successful response and it has sent the quintuplets. Okay, the next is your authentication and ciphering between your MSISDN and your SGSN. Okay, so here it will send an authentication and ciphering request. SGSN will send to the MSISDN. Okay, IMEI SV is not required in the response message. Okay, it says that the core network does not require any encryption. These are all configurable in the SGSN. Okay, so this is something that you can check. The main thing to look forward is this, that it is sending the random number, and it is sending the checksum sequence and the authentication. So authentication is something by which the MSISDN is going to authenticate the SGSN to see that it's a valid SGSN that is sending the request, and the random number is going to be used by the MSISDN, by the user equipment, to create the expected response, or the service response that is going to be compared with what was received from HLR. Okay, so and this is the response from the user equipment to the SGSN, authentication and ciphering response, and this is the response. This is the expected response of the authentication parameter response, which is received by the SGSN. And then what SGSN will do is that based on authentication sets and by SGSN, SGSN validate the authentication based on the calculation result. So SGSN will use this, and it will compare this with this XRES that is received from HLR. And if these match, in that case, it is going to allow the MSISDN to be authenticated and allow it to continue the procedure. If it does not match, in that case, the SGSN will realize that the user equipment is not authenticated. It is not a valid user equipment. Somebody is trying to spoof the network or something like that. So it will not allow the user to get attached, and your procedure is going to fail. Okay. So next is your security mode procedure. The security mode procedure belongs to the NAP protocol. I mentioned that I interface. The protocol running is a radio access network application part. So during this procedure, SGSN sends the encryption and integrity information to the RNC. Okay. So you send a security mode command and then you receive a security mode complete message. So this is security mode command message which is sent from SGSN to the RNC. So you send an integrity protection information. If you open this message, you will see the protection algorithm 0 and protection algorithm 1. So there are two algorithms which are sent, and then you send the encryption information as well. So you are basically offering, and there are two options. One is that there is no encryption. The other one is that standard UMTS encryption number 1 and encryption number 2. So these are the algorithms that SGSN is sending to the RNC, informing that these are the algorithms that I support. If you are going to choose from these, because this is something that I support, and then based on these, we are going to encrypt the information, and we are going to ensure that the integrity is ensured. And the key status indicate that encryption and integrity information is new or used. So this is something that you need to look into when you're analyzing this command. Then you have the security mode complete analysis. So security mode complete analysis means the RNC responds back. And here you can, it's very clear that chosen integrity algorithm is UIA1. You see that SGSN offered 2. So either choose 1 or 2. So it was chosen UIA1. And the encryption algorithm that is chosen by the RNC is the standard encryption algorithm UEA1, user equipment. Okay. Encryption algorithm 1 and user integrity algorithm 1. So these are the two things that you need to check into. Next is the common ID procedure. So what is the common ID procedure is what happened? Why is the sharing window closed? Okay. So this procedure belongs to the RANAP protocol, and common ID is used by the SGSN to send to the IMSI, to send the IMSI information to the RNC, who then binds the IMSI with the established RRC connection to support the next paging coordination procedure. So it's something that to inform the RNC which IMSI is being used, and then based on that, it is going to use this IMSI for the paging coordination. For example, if there's a paging request, then you are going to get this IMSI information is used for the next paging information. Okay. So the common ID is simple. You will send an IMSI to the RNC. Okay. Based on this. There is no response to the common ID response because you're just sending the information to it. There is no response that is expected from RNC on this. Next is your location registration and insert subscription data procedure. So this is the procedure where you perform the location update with the HLR, and in the response, the HLR send you the subscribe information, the API, and the quality of service, and all that information to the SGSN. Okay. So you will send a map service request and map service confirmation. These are the request and the response message. And then there's going to be insert subscription data, which is map service indication identity and the map service response, which is used by the HLR to insert the subscription data to the SGSN. Okay, so this is the message service request analysis. It is a location update request. Here you are going to send the IMSI of the number. Here you are going to send the GT of the SGSN, and here you are going to send the IP address of the SGSN. This I believe is in hex format. The trace that the training slide that captured this hex information. I captured the traces of my number as well, so we will just have a look onto the traces as well, and those will have a little bit more elaborative information, so it won't be in the hex format. Okay, and so these are the two things, and some other capability information that SGSN supports, like it says that it's a LCS capability that is supported. But the main thing here is the IMSI and the SGSN information that is sent. This is the service indication analysis. Okay, this is the response. Okay, this is the response that is sent by the HLR. Insert subscription data argument, and here it will inform that okay, this is the MSISDN, and this is the GPRS subscription data information. And in the subscription data information, we have the PDP, we have the quality of service information, that which quality of service information is assigned to this MSISDN. So you have the reliability class, the peak throughput, the precedence class, the mean throughput. Usually we're not concerned with this until and unless we are looking into that there is a complaint of subscriber having low speed and throughput. So we just check that okay, what sort of quality of service is being sent by the HLR. Other than that, this will not respond. The main thing that is here is the APN information. So it will send that okay, this is the APN or multiple APN that the user has subscribed to, which are going to be sent. Okay. And then this is an SS subscription data response. SGSN response to the indicating that all the subscription data has been received. This needs to be done because if you do not send an acknowledgement, then HLR will continue to send this message again and again after a specific timer that is configured in the HLR. So it will result in your signaling choking and all that. So this needs to be done, that HLR needs to inform with the response of that I have successfully received this information. And then there is the acknowledgement which is sent by the HLR, which will send the update location request response. Okay, so you have update location request. Based on that, its response is going to be the insert subscription information. Then SGSN responds back that okay, it's subscription received. And then HLR is going to send a confirmation that okay, the location information I have successfully received, and I have captured the SGSN location information with me. Okay, so this is done. Okay, so next is your attach accept analysis, your attach accept message. So once the SGSN gets that, the SGSN is going to send an attach accept message to the user equipment. So after collecting the subscription information, the SGSN judges whether the subscription is allowed to access the system. Obviously, this is something very this is something that needs to be checked, that even your subscription information has been sent, maybe there is no subscription information, maybe there is no APN assigned. In that case, the SGSN is going to judge that okay, there is no subscription, or maybe the subscription information says that the user cannot use the service. So maybe your roaming GPRS is barred, or maybe your GPRS service is barred and your MS is outside the PLMN, something like that. Okay, so based on that, the SGSN will send an attack accept to the message if the service is allowed. The message belongs to mobility management, this you already know, and it is sent over the IUGP interface. And in this message, the PTIMS is reallocated. Okay, so the next time the MSISDN uses, it will use the PTIMS and not the IMSI. Okay, so this is the message. SGSN sends the attach accept message to the MSISDN, and it will send the routing area update time. If you remember, I told you that there are two types of routing area. One is the periodic, and one is your based on your location change. So the periodic routing area update timer is a timer that is defined in the user equipment, and usually it's 54 minutes. And once the 54 minutes have passed, irrespective of whether you have changed your location or not, the user is bound to send its routing area update to inform that okay, I am currently attached to the network, I am currently available. So it will refresh its location update. So this timer is sent by the SGSN in this attach accept message. Okay. And the PTMZ is sent. So allocated PTMZ is this. The identity left is the PTMZ that is being sent by to the MSISDN. And the task complete is sent by the MSISDN. Why it is sent? Obviously, if it is not sent, then the SGSN will keep on sending the attach accept message. So it will result in bombardment of signaling. So you have to ensure that you send an acknowledgement to the SGSN that okay, I have received your attached request. So this is your attached complete analysis. You'll see the attached complete message. Okay, so this is what the analysis is. Let's just check the trace as well that I captured. With this, the trace screen, is it visible? Right? I think it should be visible. Okay. Okay. So here you can see attach request, the map service request, service confirm authentication, siphon request response, identity request response, then again map service request and confirm, then security mode, common mode, update location request, security mode complete. Okay, so just let's open this attach request. Let's see what do we have there. So here you'll see that there's so many information that you just get confused. So you just have to look for the information that is required by you. The other information, there is no need to go into this because you're going to get confused. So you can say the route, this service area ID, the location area ID, and the LAC. Okay, here you'll see that it is an attached request. Here it will, whether it's a PTIMZ or IMZ. So here it mentioned that it is an IMZ. So this is my IMZ. Okay, and again the location information. Okay, so this is the main significant thing is your PTIMZ or IMZ and your location information. MS radio accessibility is not required. This is something related to analysis of from radio and all that. So you see there's so many information, but the main significant information is your location information and your IMSI information which has been shared. Okay. So the next message is your map service request, which is going to be sent to. So you're going to send your IMSI information. Okay. Send authentication info. This is being sent to the HLR. So this is the message. And what you're sending your IMSI, and you're sending how many vectors are required? Five are required. Okay. And this is going to be the response from your HLR, which is going to send a certification information response. And here it is sending you your different random numbers, your different your expected response, your keys, and your authentication information. So this is in hexa and this is in binary. This is what it is sent. Next is your authentication and ciphering information, which is sent by the SGSN to your MSISDN. Here, what you need to look into is, there is something you can check, but the thing that you need to send is this authentication and ciphering request, and here it is going to send the random number and it is going to send the authentication. Okay, and ciphering not used and IMSI not MICA. This already we discussed. This is the response from the user equipment. Again, we come down. Usually, most of the information is at the bottom. So this is the response. It is going to send your. You can now see your authentication response. This is your authentication response, which is obviously then going to use by the SGSN to authenticate that okay, this express response is fine. Okay, next is your identity request. Okay, this is to get your IMEI information because we may have the GF interface enabled and we need to check the IMEI. So this is an identity request and it is asking that okay, I need an IMEI from the MSISDN. So MSISDN or user equipment is going to send the IMEI information. So this is IMEI information in binary. Okay, next is the check IMEI argument. You have the IMEI, now you need to coordinate with the EIR, Equipment Identity Register, and you will send the IMEI, you will send the IMSI, and you don't need to send the MSISDN because what's supported is this. Yes, MSISDN you can send. This is something configurable. We were just trying to enable the S13 interface, and we got to know that okay, their MSISDN is although not required, but you can send. On EIR, you can, or usually the ADM platform is being used. So you will see that there is a combination of IMSI and IMEI. There's no combination of IMSI, MSS, so that is not required. So these are the two information that you send. And your EIR is going to respond back to check IMEI response that this user is whitelisted. So you can use the service. Otherwise, you will not be allowed to use the service. Security mode command is, so you're sending the integrity algorithm 1 and 2, you're sending the encryption algorithm, either no algorithm, algorithm 1 or algorithm 2. Skip it. Let's skip this. Okay, so its response, okay. Usually what happens is that you will not see the messages in sequence. Okay, so we send a security mode command and then you said you're sending a location update. Okay, so what happens is that because security mode command is on the left side from SGSN to the RNC and update location to HLR, so maybe it's being processed in parallel, or maybe because this is all happening in milliseconds. So 1-2 millisecond delay at any end, so messages get a little bit up or down. So there is no concern in that as long as SGSN is getting the required information response within the time allocated. Okay, so what we can do is that we can skip this. We can just check that, okay, where is this is the security mode complete. So it has chosen this integrity and this encryption algorithm. Next is your update location request. So you will send an update location request, and here you're going to send the IMSI, okay, and the PLMN information to the SGSN. I don't see any SGSN location information here. Let's just check it in the next message. Okay, so in the next message, so that is just the update location, but since the communication is done on the map, so here you're going to see the actual information. The actual information is going to be this. So this is the argument update location request IMSI. This is the SGSN address. It is an IPv4 and the IP address is this 119.160 this. Okay. And then you are going also sending the GT of the SGSN. This is the GT of the SGSN. So it's 9230 something. Okay. In different vendors, there is a different way of reading the messages. Specific in Huawei, you read it backwards in the combination of two. So you're going to read it like this: 923089824004. I don't know why this is, but this is how it is. So I mean, every vendor has a different procedure of reading this. If you have a Huawei equipment, then you need to read it like this. You'll get accustomed to it with time. Okay, so security mode complete is checked already. Okay, this is the common ID. In common ID, you're sending your IMSI to the RNC. Map service indication is the response of your subscription data. So this is insert subscription data argument. So the PDP context. So each APN which is provisioned in the HLR, it has a context ID. This context ID identifies the priority of one APN over the other. If you remember, I told you that if you're sending a wrong APN, then there is a feature available in SGSN that it can use an APN auto correction feature. What APN auto correction feature that if you're sending a random APN ABC 123, then SGSN is going to reject your request because that will result in huge number of rejections. It will assign you the default APN, the APN that has the least context ID. So least means the one has the highest priority, then two, then three. So this context ID is then required to identify the which APN has the highest priority. Highest means lower number means highest priority. So this context ID of this APN, and this will be an IPv4. Then this is the quality of service information associated with that, throughput, delay, class, reliability, then this is your character string, the APN that you will get. Every vendor has a different, or every operator has a different. Okay, so extended quality service, this is something not usually required. Okay, maximum. So main thing required is that your information regarding to this. So update location answer, this is going to be the acknowledgement of that. Okay. Update. So this is going to be the response that okay, that I have received your update location request and has been. So and next is going to be your attach accept message. Why is it showing peer to MME or vice versa? Why not showing node name like message is sending to EIR? That this is configurable in the trace system. Sometimes it is showing to the peer if you're not mentioning the nodes. Sometimes it is. So this is proprietary. This is vendor proprietary. You cannot question this. This is how it is configured, how it is developed. Every vendor have their own mechanism of how to share the how to show the traces and all that. So this is something that um I mean, you can, if you're working in an operator, you can ask your vendor for this. Maybe they have a valid explanation of that, or maybe it is something that is by default designed by the R&D team. But if you are enabled on this, then you don't need to know that which we can open a message and you can identify okay which sort of which any is it communicating with. So attach accept message. Attach accept message. What we're going to look for is your PTMZ. PTMZ signature, PTMZ. You can see the location of but the thing that is required is your PTMZ and your location and your routing area update timer. Okay, and then so this is the attach accept message. I don't think I captured the attach complete message. The attach complete message just an acknowledgement of this. That okay, I have okay. So this is a little bit of analysis of your 3G attach procedure. But there are many maps that will require to note that message. You open up that message, you see which sort of message I just showed you. You need to this is a map service request and usually map service confirm. With HLR, this is or with other nodes, it's the service request and service confirm thing that is done. Okay. And when you open the message, you will identify that what is it. So send authentication information is going to be with HLR. It is not going to be with EIR. Okay. And if you open this message, you will identify that this is what check. So check IMEI is going to be with EIR. So I mean, if you are also getting this, then you need to open up the trace. You need to know which message to open. So those messages are mentioned. And again, here the communication is with HLR. So you will identify that okay, what is being sent by the HLR. So this is the insert subscription data. So insert subscription is being done by HLR. Okay. So this is how it is going to be. And this is the service request. The service request is what? This is update location. So update location will be sent to HLR. Okay, so I believe the attach procedure would be clear to you of what to look into. The main information that you need to look into, which will help you in troubleshooting. I mean, if you get lots of failure and all that, so you can just capture a trace on one number or a random number trace, and then you can identify if there's any problem with attach. So you will be able to identify that where this problem lies. Next, we're going to cover the PDP active procedure analysis. Okay, so that during PDP active procedure, the data transmission is established for MS to visit the external PDN. Yes, obviously, or based on APN. And the interfaces involved are IU and GB, GN interface between GGSN and GI interface with ISP. USN can provide signaling tracing function on different interfaces. So you can capture an interface trace as well. That is a bit complicated to analyze and all that. We will just look into these traces and then maybe at a later stage, maybe we can look into the interface traces as well. So a little bit of overview of how your is done. We cannot see your screen. Oh, this is strange. Okay, sorry, I was sharing the screen. Let me. Okay. I hope it's fine now, right? Okay, now it is fine. Good. I was sharing that the traces one. Okay. Data transmission. Okay, so this thing. Your three interfaces are involved in this. Okay, and an overview of the PDP in 3G. You send an activate PDP request to SGSN. SGSN will internally do the identification of GGSN based on DNS. It will send a create PDP context request to GGSN. GGSN will do its internal. So in this session, I am just covering the SGSN presses. Okay, in the next session, we will cover the GGSN presses. So then we can see the end to end that, okay, once you get the create response, so what happens here? Okay, and then what happens here? So we'll just covering this part. So what is happening here? So attach request, then internally the DNS communication, then you send a create PDP contact request, create PDP contact response, then your RAB assignment request, RAB assignment request response, then update PDP request, update PDP response, and activate PDP contact accept. This I believe if you remember the RAB assignment request is to ensure that a radio access bearer is activated between MSISDN and the radio part. Plus, it is also used to communicate the direct unlink feature. DT feature, its details I'm going to cover in the next session, where I mean the next session can be for GGSN traces, and then after that we can have a look into the basic features like DT, SGSN pool, MME pool. So once you will have a better understanding on that. So because of that DT, and if there is any change in quality of service, this update request. Otherwise, the update request is not required. So you send the DT feature. Based on DT feature, you will send the signaling and the user IP addresses to the RAN, and the RAN is going to send its signaling and user plane IP addresses to SGSN. The GSM will inform to GGSN. We'll have a look into it in the detailed procedure as well. The full procedure is traced by using subtrain function. Main steps are these: initiate the PDP context, it will check the subscription data, it will perform COS negotiation, APN resolution, and send a create PDP request to the SGSN. To GGSN. The GGSN, once it will perform QoS negotiation, check the APN, allocate the IP address, and respond back with this response. Then we have the RAB assignment procedure, and then they have the activate PDP accept message, giving the IP address to a user so that he can use the service. Okay, so these are the main messages: activate PDP, create PDP response, RAB assignment request. Again, you'll see the RAB assignment request is first and response late, and then but this message is received because of the millisignaling or a little bit of delay. The messages get a little bit up and down in the tracing, but usually it's request response, and then based on that you send an update request, update response, and then activate PDP context accept. Okay, so this is an activate PDP context request which is sent by the user equipment or MSISDN sent to the SGSN. So what does it send is that it sends the NSAPI. You send a network service access point identifier. This is usually based on the APN. I mean, and every user is assigned an NSAPI. Like you have a bearer ID in 2G, 3G, it's NSAP ID. This is not usually, it is usually 5, so you don't need to worry about that. This is the quality of service information that MSISDN shares. Okay, this is the quality of information that I require for this service. Okay, what sort of bit rate, what sort of precedence, and all that. So this is quality service requested, and then you send your which sort of PDP type is required. PDP type is IPv4, and then you send your APN as well. That for which APN do I need to get the PDP activated? Okay, so internally, the internally communication usually is captured in the internal messages. I'm not covering the internal messages here. It will be a bit complicated. Maybe if you guys are done with this, then I will capture the whole trace, including the internal message, and then I'll see that, okay, what internal communication happened. But usually we go into the internal messaging of a node if we don't find anything here. Okay. For example, you get an activate PDP request, and maybe you get an activate PDP reject, and based on the rejection cause, you seem to identify that, okay, that APN cannot be resolved. Then you will check the internal messages that, okay, when the SGSN sent it to the DNS, or when SGSN sent the request to its internal the internal cache or its DNS cache. So what was the response received? Which APN was sent? What was the response? What was the cause code? So all that is done in the internal messaging. Right now, at this level, internal messaging is not required. Just need to understand because that is going to be too overwhelming for all of you. We will cover that in our advanced training session when we start that. Okay. So so you send a create PDP context request from SGSN to GGSN. So you will send this is a GTP header, again not required. You are sending your IMSI, you send your location information, you send your APN selection mode that this is a network provided APN subtract where the APN has been verified. Then you send the tunneling ID. Tunneling ID, like I mentioned to you, that there is a tunnel, a virtual tunnel is created between one node and another. And if I think the document of quality of service that I sent, if I sent a presentation with it as well, that PPT has the tunneling information and bearer, it is an advanced concept to understand how that is done. A little bit in the later stages, we will come to that when we will discuss the quality of service. Then I will show you that how uh, uh, tunnels or different bearers are created and how it is identified. But at this level, you just need to identify that this is the ID that is used for control information and control, and this is for the user plane information. So GTP-C tunneling ID and GTP-U tunneling ID is what SGSN is telling to GGSN that I will be communicating on these tunneling IDs and NSAP, this service identifier. Then it will send the APN, that which APN is required, and SGSN is going to send its own signaling and the user plane IP address. IP address the control plane or user plane of the GN interface of the SGSN to tell the GGSN on if it needs to perform signaling, on which IP to communicate, if it needs to perform the download the user plane traffic, which IP to communicate with. MSISDN is sent, and this is the quality of service that SGSN will send after internally seeing that okay, the MSISDN requested this quality of service, and this is something that I also support. So this has been negotiated between the user equipment and the SGSN, and once agreed upon, it is going to send to GGSN that this is something I need an APN, I need a session PDP session that supports this quality of service information. So GGSN, what GGSN does, it will translate the APN into an IP address. It will check this quality of service information and match with what it has. Then it will authenticate the user. So all that we will cover in the GGSN process. Like we mentioned here, what GGSN does: quality of service, check the APN, allocate IP. So this is what GGSN does, and once that is done, it agrees with it. It will send a create PDP context and context response. Okay, so here what you need to see is that a request has been accepted. Next, you need to see that now GGSN is going to tell SGSN that which tunneling IDs on GTP-C and GTP-U I will be using. So there a tunnel is going to be created between the tunneling ID control plane of GGSN and tunneling ID control plane of SGSN, and another tunnel is going to be created between the tunneling ID of user plane of SGSN and tunneling ID user plane of GGSN. So two tunnels are going to be created. The signaling will go on this tunnel, the user plane will go on this tunnel. Then one more thing that the GGSN sends is the charging ID. Since you need to be charged and GGSN is primarily responsible for charging communicating with OCS, so it needs to have a charging ID. So you will have a unique charging ID for every PDP created. When you search for CDRs of an MSIGN against one PDP session, so what you're going to find is that there is a common charging ID for one PDP session is unique. So I mean, if there are so many CDRs of MSIGN and you need to search those CDR, then you can search them using the MSISD, using the IMSI or the MSISDN, but then it will give the CDRs of all the sessions available. Then to further trickle them down, you search them using the charging ID. Based on the charging ID, it will give all the CDRs pertaining to one PDP session. Then GGSN will give the IP address, and GGSN will give this is the IP address of a user that is assigned to the user, And these two are the signaling and user plane IP address of the GGSN, informing SGSN that, okay, I will be for signaling, I will be communicating on this IP, and for user uplink and downlink, I'll be communicating on this IP address. And it will send the quality of service profile, which it agrees upon, which it is supported. Okay. Next is your RAB assignment request. This was not covered in the initial slide, so this is something that I added myself last night. So in the RAB assignment request, what you send is your RAB ID. What you send is the maximum bit rate that the SGSN supports. So it's your uplink and okay, the maximum bit rate. Then you send your ARP, the allocation of retention priority, the ARP information. And the main thing that it sends is the user plane IP address on which the RNC needs to communicate. And this, if DT feature is enabled, this is going to be the GGSN user plane IP. It is not going to be the SGSN because DT function is enabled. If DT is not enabled, then this is going to be the SGSN user plane IP address. So this is the same IP address which here the GGSN has sent you, has sent to the SGSN. So SGSN will send the same IP address to. So okay, for user plane communication, you need to, for transport layer communication, you need to communicate with this IP address. And this is the RAB assignment response by the RNC to the SGSN. And here the thing that you need to note is code is 0. The main thing is this: the RAB ID is going to be the same. Yes, there is one more thing: the GTP tunneling ID. So a GTP tunnel, just like we had a tunneling ID between SGSN and GGSN, we will have a tunneling ID between RNC and SGSN as well. So this is the tunneling ID that is sent by the SGSN that I'll be communicating on this tunneling ID. And the RNC will send your GTP its own tunneling ID. So a tunnel is also created between RNC and SGSN and between RNC and GGSN as well. So the user plane traffic can communicate on this tunnel. The transport layer address, this is going to be the RNC user plane IP address. So RNC, this time RNC, you're just doing signaling. So SGSN does not know what is the user plane IP address of the RNC. When you configure RNCs, you configure the signaling IPs as well, and then you configure the user plane IP as well. So this is the user plane IP of the RNC, which RNC informs to SGSN, and this is the RAB ID. RAB ID, I believe, is going to be the same. Okay, so next is going to be your update PDP context request. This, I told you that this request is sent based on two things. One thing is that when you have the quality of service information negotiation between between your RNC and SGSN, and if there is any difference, or this is something that the RNC informed that on the response that, okay, I do not agree with this, the updated quality service is this, then the SGSN is going to re-inform the GGSN that, okay, the negotiated upon quality of service between me, between the user equipment, between RNC is this. So please update this quality of service information at your end as well. So it will send the updated quality of information if it is it has been negotiated. If it is not negotiated, it will send the same old quality of service information. And the second thing is, if you have the DT function enabled, then it needs to inform the GGSN that what is the user plane IP address of the RNC. So this is the signaling IP address of the SGSN, which is an informant user. Okay, any signaling communication you need to do, you need to communicate with me. But if you have a user plane communication, you need to directly coordinate with RNC. So it gives the RNC IP. This is the same IP address that you received here. So it is going to send the signaling and user plane IP addresses. The initial in the create PDP, the both of the IPs belong to SGSN. But now, since the DT is enabled, so the IPs are going to be changed. So, and then the quality of service profile. And the PDP context response, request accepted, which is sent by the GGSN. Okay, I accept your request. It will send the updated tunneling ID information. It will send the charging ID information. It's going to be the same charging ID information which was previously shared. The tunneling ID data is going to be the same as well. And it is going to reiterate that, okay, from my side, the signaling IP address is going to be this, and the user plain IP address is going to be this. Okay, so from my side, this is what is going to be used, and the quality of service that it has agreed upon. Then you send the activate PDP context accept message to the MSISDN. This is the final quality of service. This is something agreed upon by RNC, agreed upon by SGSN, agreed upon by GGSN, and obviously MSISDN. So this is something that is finally agreed upon, and the quality of service information is being sent to the MSISDN. And the other thing is the IP address. So the PDP address of the MSISDN or the IP address is going to be sent to the MSISDN, based on which the MSISDN is going to use this IP for further communication and browsing. Okay, let's have a little bit. Let's see the trace for this as well, just to have a better understanding. I hope the trace, this trace is visible to you. Okay, good. So this is the combined trace starting from attach. So we'll just move directly to the create PDP part. Okay, so this is your activate PDP context request from the MSISDN. Okay, so it sends an activate PDP. This is the GSM header, is not required. Run app information, location information, LAI, tracking area ID, service area ID. Okay, the main thing is this, the activate PDP context request. Here it is going to give its quality of service information, and here it is going to give that it's an IPv4 APN, and here it is going to give which APN based on which you need to create your PDP. Okay, you are saying that. Okay. Why didn't you mention this before? I've been doing this. Okay, I think it should be. It says that it is visible. Okay, I'll share it again. Now, Asan, is it visible? Okay, I'll just unmute Asan so that Asan can directly highlight it to me if there is any issue. But Asan, you need to ensure that you mute yourself once you have communicated. Okay.
ओके सर।
ठीक है, आपने मुझे अभी आप म्यूट रखो, जब कोई किस्म की चीजों की मुझे डायरेक्टली बता दिया करो, मैसेजेस की इंफॉर्मेशन ऐसे आती नहीं है, इस किस्म की चीजों का मुझे आप बता दिया करो. ओके, यू
लास्ट टाइम भी मैं ऐसे हो रहा था.
राइट.
ओके
ओके
प्लीज.
Okay, so it means that the last traces I shared, you guys didn't see anything. You should have mentioned to me. I mean, these traces that I am showing, my own traces, these may be the ones in the message, the ones that are being. You should have told me, Wasim. The ones that are in the slides, those traces are basically covering maybe 70 or 80%. Just 20% more information is captured here. Once you will capture the trace, once you open it, you will just recall it. Okay, so here, okay, I hope it is visible now. So I think what I can do is, just to ensure this, is that I can share my whole desktop with you. Let me see. Let me just share my screen with you. Okay, so I think now this won't happen. Ahsan, visible, the PPT is visible to you, right? Okay, and now the trace is visible, right? Okay, and now this the message window is also visible. Okay, right? Good. So okay, I've shared whole of my screen with you. I'm not sharing. Okay. Okay. So So where were we? We were here. Okay, so here the PDP type is IPv4. Here you will see that this is the APN that is being requested by the MSSDN. Okay. The next message is going to be a create message, create PDP context request message. Again, it is a GTPC request. So this is the signaling. This is the local signaling IP. Local signaling. This is the SGSN IP. Peer signaling IP is the GGSN IP, and this is the port on which they are communicating. Come down. This is the IMSI. So create PDP request v1. Okay, so this is the create PDP request. The version of GTP I already covered for 4G. It's GTPC version 2. For 3G, it's GTP version 1. So it's version 1 since we're covering the 3G cases. So location information. This is the tunneling ID for data, tunneling ID for control, NSAPI. This is the end user address. End user address that, okay, this is the IP that is requested, and this is the APN that the user has requested. Okay. And then it will, SGSN is going to send its own. This is its signaling address, and this is the user plane address of the SGSN. So if you remember, I told you that in the create PDP, SGSN will send its own signaling and user plane addresses because DT is not visible at that time. MSIGN is sent, the quality of service is sent, the RAT, which RAT technology, it's UTRAN means 3G is sent, the location area is service area identifier SAI. What is it? It's PLMN ID plus location area code plus service area code. Time zone supported and the IMEI supported. So all this information is visible. The right, Asan? Anyone? All these messages were visible to you, right? Okay, that's great. Why can I not? Just check. This is okay. Let me just. Okay, I've asked you to unmute. You can keep yourself unmuted, but then ensure that there is no background noise. Okay. Where is LAC and RAC information in this trace? Here, देखो ये यहाँ पे है. Here it is. It's the PLMN ID, the LAC, and the RAC. And what is that happens is that then you have the cell ID information as well, which is the service area code, which is over here. So you have the service area code over here as well. Okay. Good. Okay, so what I can do is that for the attached trace, I can just show it to you guys again once we are done with this. Okay. In which message, LAC and RAC, the message is the same. Message is the same. Message is this one, create PDP context request. Okay, this is the create PDP context request message. Inside here, for Huawei specifically, I mean, you have to search the location area. This is the routing area information. In other vendors, it will, but it will be inside this message. Always. In which field, obviously, that is going to vary, but it's going to be something. This is the PDP context response. Okay. So still communicating on GTPC. Okay. So the local IP address. Okay, this is the GGSN IP address. The peer is your sorry, local is again SGSN and GGSN, the IPs. And here, because we are capturing it on SGSN, so the local is still going to be the SGSN and the peer is going to be, if we capture on GGSN, it's going to be inverted. Okay. So we come down to create PDP response. First thing is request is accepted. The tunneling ID data, tunneling ID control, and the charging ID information. Okay. This is the IP address type, and this is the IP address that is assigned to the user 10.38.136.88. Then the GGSN signaling is to be done on this IP. The GGSN user communication is to be done on this IP. And then the quality of service profile. If I can share the document, this is available in 3GPP. You can capture this, you can, I shared you the 3GPP documentation as well. Or if you are working on PS4, then you will have the specific vendor document. It will have that. Or I think the main thing is to, or the ideal condition is going to be that you use the 3GPP documentation. Which fields and all that, this is vendor specific. So even if I share you this, maybe you're working on Nokia, you're working on some older version or newer version of Huawei, you may not be able to find this. So the thing is to understand how to capture a trace and understand how to read a trace. If you know how to read a trace, you will be able to identify this information. Okay. Uh, uh, you can also convert this into Wireshark trace as well. In that Wireshark trace as well, I mean, if you convert it to PCAP, then in that case, every vendor trace becomes the same. Okay, but the PCAP one, we can discuss that as well, but I haven't used that very frequently. I usually use these traces for troubleshooting and all that. The Wireshark one, maybe we can cover it. I'll just get myself enabled on that, and then maybe we can have a session on checking the same traces on Wireshark as well. But this is specific to vendor, and what I would recommend is that instead of just remembering where to find what, you just open up the trace and then you browse through the trace, and with time you will able to identify that okay, which field is found where. Okay, so the next message is your RAB assignment request. Okay, so RAB assignment request maximum bit rate information is this. Then what I told you is that preemption capability, preemption vulnerability not required right here. The transfer layer address, this is the IP address of the GGSN, and this is the GTP tunneling ID. Okay, and then it is also informing that the PDP type is going to be based on IPv4. So these are the main information that is contained here. Like I said, let's just check the RAB assignment response. This is the RAB assignment response. Again, this is the RAB ID is going to be the same. The tunneling ID is going to be different from RNC, and this is the IP address of the RNC that is received in the response. So update PDP context request. I mean, this is the same thing that we covered over there as well. I captured it from here. So you will check the local signaling, the peer signaling IP, the GTP head, the location area information. This is the tunneling ID. And this is the signaling and the user plane addresses. So if you see, previously the user plane address was also 119 dot something. Now the signaling is the SGSN IP, but the user plane IP is 10.227.4. This is the same address that is shared by the RNC in your RAB assignment response. Sure. The Wireshark one we will do later. Okay. So this is the user plane address of the RNC that you're informing GGSN that you need to communicate directly with RNC. And this is the quality of service information. Then you have the RAT information, you have the service area identifier information, the time zone, and the DT flag. So DT flag is enabled, which is informing that okay, you need to enable direct tunneling. You need to create a direct tunnel with RNC based on that user plane. So DTI flag is 1. If it's 0, then the DT is not enabled. And this is the PDP. This is the update PDP context response. Peer IP address signaling. We can skip this part. This is the response. The cause is accepted. The tunneling ID, the charging ID, the GGSN's signaling address, the GGSN user address. This is a problem in the trace. I corrected it in the slides. This is GGSN address user plane. This is the user plane address of the GGSN, which needs to be informed to the RNC that okay, this is the user plane address that you're going to use. The quality of service information that is supported, and that's it. Okay. Next is EMS signaling is not required. Activate PDP context except. In this except message, what we need to look into is location area we already know. Here, activate PDP context except the quality of service that has been negotiated upon and agreed upon by all the nodes. the priority level. This is the PDP address. PDP is IP, is form is IPv4, and this is the IP address which is in binary. So you converted it's 10 dot something dot something dot something. So this is the IP address that is assigned to the MSISDN. Okay, and I mean we covered this already. Okay, so this is something that you guys missed. Is the opened trace visible? Right? The explanation. Okay, now it's visible. Okay, so in attach request, what I told you is to look for the location information, the 11 ID, the RNC ID. Okay, and the main thing that you need to look is PTMZ or IMZ. So it's the IMZ that has been sent. The old location area information, the MS radio accessibility is not required. That's it. So main thing is your IMZ. You need to inform the IMZ. You need to inform that okay, it's attached type. Yes, the attached type was also there. The GPRS attached, and your IMZ and your location. Okay, so map service request. Send authentication information. You're sending your IMZ and you're sending how many requests, how many vectors are requested. Then this is the response from HLR. HLR is going to send you this quintets. Okay, so authentication. So Yasir, this is something I didn't know at that time. This is not visible to you. So what I'm saying is that there, what you asked was that so many map messages. So this is what that you open up a message and you identify from this message. If it's send authentication info response, obviously it's from HLR to SGSN. If it is map service request for this thing, SAI, send information argument, obviously this is from SGSN to HLR. So based on this, you are going to identify that which node is it. Okay, the next message, authentication and ciphering request. So you are going to send your this thing, the charging, you send authentication information request. You're sending the random number, you're sending the authentication to the MSISDN. And the response of the MSISDN is going to be the expected response is this is the expected response. Apart from other things, the main thing that is required is here. Because I already covered it, I'm just going through the screen so that you guys know what information to look. Okay, then this is your identity request. So you're sending an identity request. You're asking that show me your IMEI, and the MSISDN responds back with the IMEI. This is the IMEI that is sent along with the MZ. Then again, it's check IMEI argument with EIR. So you're sending the IMEI and the IMZ information. It's a combination of the two. And this is the response from the IMEI. It says that it is whitelisted. I think the messages are visible to you now, right? I hope the screen is visible. Great. Okay, security mode command. Like I told you that these are the two integrity algorithm, 2 and 3 encryption algorithm that is sent to the RNC. That okay, these are supported, and I think the response was a little bit late. The complete is this. So the algorithm supported by the RNC is these two. So it will respond back in security mode complete. It's coming back. So you send an update location request to the HLR. Here you're sending the IMZ, but the detailed you're sending your IMZ, and here you're sending the detailed information. What you're sending is your IMZ. SGSN is sending its IP address. Here is the IP address, and this is the GT. So this is what I was mentioning that you have to read it like this: 923089804004. So this is how you read the GT. Majority of the information is read like this. Some of this is mentioned, or easier way is to get it like you have it available in binary, so you can get it translated as well. Security mode complete, we already covered. The common ID, IMZ, you're sending the IMZ to the RNC. Map service indication, again, What message is this? Between which two NEs is this? You just look into what. So insert subscription data means it is from HLR to SGSN. So the PDP context ID, what I was mentioning, the PDP context ID, each APN has a context ID. The lower the context ID, the higher the priority. So every APN, I mean, if I have multiple APNs, I will be giving context ID 1 is this APN, context ID 2 is the other APN. It is an IPv4 APN. This is the quality of service of this APN. This is the actual APN, extended quality of service. Okay. So the main thing that is required is this, your APN information or your quality of service information. Okay, update location answer, just an acknowledgement, response of that okay, I have received the update location. And then you get the attach accept message, sending to the MSSDN. Here, the main thing that you need to look for is your, I mean, location is already known. Okay, GPR result is GPRS attached only. It is only attached via GPRS. There is no location area attached. Okay, no MZ attached. Then your allocated PTMZ, it is TIMZ or PTMZ, it is going to be TIMZ. Okay, selected that. So this is your identity, PTMZ information. Okay, and this is the signature, the PTMZ signature. Sometimes signature is used, sometimes the whole PTMZ is used. So attach accept is also done. Okay. So this is the whole. So we covered attach, we covered the PDP as well. Let's just cover. I think we can take a 10-minute break. Okay, and we'll start at 6 and then maybe wind up in the next half hour the routing area update procedure, and see if we have time we can look into 4G tracer. Okay, so let's just have a break of 10 minutes, and then we will join. Okay, everyone, welcome back. How many of you are here? 25 people are here. You want to record this session, path of the recorded file. Actually, the previous recordings I used to share with you guys, but this time, because the traces are Huawei specific and all that, so maybe let me just check it internally. If I can share this or not. If I can share this, then obviously I will share it with you guys. Otherwise, what I can do is that from the next time, what I will do is I will enable you to capture this recording. You will have the capability of recording as well. I will allow you guys to record. I will see how it can be done. So, but right now, let me just check it with the concern, if there is any concern for that. Okay. Okay, so let's resume. I believe my screen is should be visible to you guys, or it's not visible. Let me just share it. And this time I will share my full screen. Okay, so you guys won't have any issue in that, and I'll have the chat box with me as well over here. So the screen is visible, right? Okay, so it's visible. Okay, that's great. So next we'll come to 3G routing area update procedure. As we discussed, routing area update procedure, location registration on the network side for subscriber entering a new routing area. The new SGSN obtains the subscribers mobility management and PDP context from the old SGSN, and it obtains the subscription data from HLR. So the two things that are involved is the IU and GB interface, GR interface, and then there is GN interface as well between one SGSN and another. This is, I mean, if you're talking about inter SGSN routing area update, and this trace can be enabled at SGSN end. So an overview of this is that routing area update to new SGSN, if it was connected to an old SGSN, so context request, okay, and then SRNS context request from old RNC, response of that, the context response to the new SGSN. Then you have the security authentication. Then if your data packets are buffered on RNC, so you will request for that. Those packets are going to be forward to the old SGSN. From old SGSN, they will be sent to the new SGSN. Okay. Then you will update the PDP context informing GGSN that the SGSN has changed. You will inform HLR the location has changed. HLR will obviously cancel the location. It will insert the new subscription information, acknowledgement of that, update acknowledgement, okay, of that, and then this is or combine attach. No need to location update accept again from VLR. So this is the location update acknowledgement received from HLR number 13. 14, 15, 16 you can skip. 17 is routing area accept and routing area complete. Okay, so this is an overview, and now we will see what are the messages in the tracing. So MS initiate says SGSN get GGSN address from DNS, obtain the context from old SGSN, initiate authentication, security mode, common ID, update PDP to the GGSN, HLR perform the location registration and insert subscription covered in the attached one. Send the routing area accept message to the MSSDN, updates its PTMZ and inform SGSN, initiate the signaling connection release procedure. Okay. So here we are. The MS will initiate a routing area request message. SGSN, this is an internal DNS, so it gets the GGSN information from DNS. And SGSN, this is then is the context request message and context response message. Then the authentication procedure to be done with the MSISDN, SGSN to MSISDN, its response, then security mode command, security mode complete, common ID. This already we have covered. Okay. Then you send a GGSN context acknowledge message to the old SGSN. Okay, so there's GGSN context acknowledgement. This is the context request, context response, and this is the context acknowledgement. Then update PDP context request to the GGSN, its response. No, its response is not mentioned here. This should be corrected. It should be GGSN to SGSN. Its response. Okay, here we have the response here. Okay. Then this is the map open request and response. This is basically the update location information to the HLR that needs to be done. So it's maps service request and its response. Okay, this is a service request, and this is again the service request. So this must be the service request for authentication with EIR. This is the communication with your HLR. Okay, over the GR interface. This is your service response to the insert subscription information and the location update response. Then the routing area update accept message. Okay, and then MSSDN has changed the PTMZ, so it will confirm that PTMZ allocation it has been updated, and your IU connection has been released. So let's have a look into the message details. Belongs to mobility management. Routing area update is done when you enter a new routing area. Based on the network information in the broadcast message, determine the update type and uses the PTMZ as identifier. So this is your request analysis. Okay, indicate that no service needs to be set on MS subsequently, and IU connection needs to be released after routing area is completed. So there is no follow-on. There is no any request that MS is going to send. So once you have updated the routing area, you can release the IU. The IU link so that it can be used by other subscribers as well. This is your location, and this is the old RA. So here, the old routing area ID is going to play a significant role. So this is the old location information based on which the SGSN will identify the old SGSN. Old PTMZ signature, and this is the PTMZ, and this is the current network capability. Capability is usually we don't have to worry about this. This is usually done when you have using some specific service needs to be used and whether it's capability. This you can go read more deeply in 3GPP documentation. It will give you a more elaborative of why this is used and how it is used. So this is SGSN context request analysis. Okay. So from one SGSN, from new SGSN to old SGSN. So local and peer IP address and ports. Local and the peer one. Then we come down SGSN context request. So it gives the old routing area ID and it gives the old PTMZ signature of the MSISDN. So this is the context response sent from the old SGSN to new GGSN. So here the request is request accepted. Here it will give against the PTMZ, it will give the IMZ as well. Okay, this is the IMZ. So if IMZ is given, then there is no need to perform authentication or identity request with MSISDN. Then it will give the tunneling ID control pane. This is the control pane tunnel ID from my side. Then mobility management context and PDP. So mobility management context information, if you open here, it's this. It will give the authentication sets that are available with the old SGSN and the network capability and the number of vectors. So it has 4 vectors available. Total is 5. So currently it has only 4 vector. 1 has been already used. So those 4 vectors it is going to share with the new SGSN. And in the PDP context, it will give the quality of service information. It is going to give the IP address that is allocated to the MSISDN. It is going to give the GGSN control pane and the user pane IP address on which the SGSN is the old SGSN was communicating. So the new SGSN can then communicate with the same GGSN in the and via the update PDP context. And this is the APN that the user was using. So based on all this information, the new SGSN is going to realize and then it is going to send this update PDP context request. So okay, so it has this information from old SGSN that will update information to the GGSN. So this is the acknowledgement sent by the new SGSN to old SGSN, request accepted, and it will inform the address of the SGSN user plane. So just informing it that this is the user plane. Update okay, context acknowledgement analysis. Okay, next is your update PDP context request analysis from new SGSN to GGSN, and obviously it's the old. We're talking about the GGSN change, so it's old GGSN. So here you're sending your IMZ. Here you're sending your tunneling ID data and control plane of the SGSN. Here you're sending the user plane and the signaling plane IP addresses of the SGSN. Then you're sending the quality service profile supported, and you're sending the user location information, which is the service area ID. This is the specific the specific cell ID in 3G is the service area code. This is the response from GGSN. It says that okay, request is accepted. The GGSN will send its tunneling ID of data and control plane. It will also send the charging ID. Then GGSN will also send its signaling and user plane IP addresses, and it will send the quality of service information that it has agreed upon to the SGSN. Routing area accept procedure. So now routing area accept is going to be after collecting all the subscription information inserted by the HLR. The HLR subscription thing has been missed here, but that has been missed because it's already covered in the attached one. So it's going to be the same. You're going to send an update location to the HLR, and in that you're going to send the updated, the new SGSN IP address, its new context information, and the IMZ. The HLR will then respond back with the authentication sets. Yes, what we are going, the new SGSN is going to do is that since it received 4 vectors here, so when it sends the location update request, it will just ask for 1 vector. It will say, okay, I have 4 vectors available. At all the time, I should be having 5 vectors available. So it will just ask for 1 vector, and HLR is going to respond back with just 1 vector. And then you're going to send, SGSN is going to send the acknowledgement to HLR for the context have been received, and HLR will send the acknowledgement of the location update. So HLR will have that, and plus HLR will then proceed to remove the location information and the context information from old SGSN as well, which you can see over here. But this you will not be able to capture on SGSN, only on the HLR. Yes, if you have trace enabled on both the SGSN, then you can see this information. Okay, so here what it does is this information, the cancel location, old SGSN, and cancel location acknowledgement, and based on that, the old SGSN will have the IU release command and IU release complete. Okay, so so this HLR communication is done, then your routing area accept is sent. This message belongs to mobility management, and here the PTMZ is reallocated to MSSDN. So this is your result. Routing area is updated and routing area update accept. Here again, you will send the periodic routing area update timer, the current location of the user, and the updated PTMZ. So if SGSN reallocates a new TMZ, the message must carry the new PTMZ to the MSS temporary subscriber identification. Routing area update complete. This is after receiving the PTMZ, the MS will update it in its card and it will send a routing area update complete message to notify SGSN of the accepted new PTMZ. Okay, so it will send an accept informing that okay, I have accepted this new PTMZ. Because you're able to master attached procedure routing area PDP. So I believe for routing area the trace I was not able to replicate this because I'm sitting at home and I was not able to move from one routing area to another and enable a trace. So something I did try to do. Let me just check if I was able to simulate this somewhere. It was in one of the messages. I tried simulating it using 2G and 3G. I from my handset I changed from 2G and then to 3G. So let me just check. This should be here. I hope that I get this information here. Okay. So this is basically an intra SGSN. Okay, the SGSN is not changing. So you will not see all the messages here, the security mode command and all that, but just a little bit of info on how it works. Because I moved from 2G to 3G, so obviously my routing area got changed. So this is something that I was able to capture. Okay, so this is my old routing area information, the LAC and the rack. Okay, and the service area identifier, just the ID information. Okay, and then I will then the handset center routing area update request message, and what is follow on request is pending. So there was some transmission and all that. So it said that follow on request is pending. There is one request pending for uplink and downlink because it's usually not possible for you to stop this when you're using a smartphone. So many applications in the background, so you always have your PDP connected and all that. So here it says that okay, there is a follow on request pending, so you will not have an IU release. Okay, so this is the capability. Capability is not of our concern. Let's come down. The old PTMZ signature. This is giving the PTMZ, the current PTMZ that is being used. Okay, and it is giving that this is the current PDP, this is the current IP address. Okay, the current IP address that I'm using and the current PTMZ that I'm using. So this is the information that it has given in the updated in the routing area update request. The main thing to note is the PTMZ and the old location area information because that is something that is being used by the SGSN to get the information. By PTMZ, it will able to communicate with the old SGSN and get its IMZ, and by old routing area ID, it will get the location of the old SGSN. In this case, the old is the same one. So after internal communication, since this is a 2G to 3G, you can call it a handover. Okay, what is the app you use to open the trace file, please? This is application is a Huawei proprietary. If you are an operator of Huawei, or you are working in Huawei, you will be able to open it because this trace is an Huawei captured trace. This is not usually available. So if you are able to capture a trace, obviously you will have the application. You can open the trace using the same application. Okay, what I can do is that I can convert these traces in PCAP and then maybe I can share it with you. That way you can better understand it. But a session on how to read those you will have to wait for that. Okay, I can convert these into PCAP and then I can share it with you. And then maybe afterwards we can have a session on how to read the PCAP traces. Okay. But the point here is that you guys and girls understand that how that if you have a trace available, then what information and how to check this information. So it's a 3G. So the security mode command, as you already discussed, I will just cover it briefly. Security mode complete, the chosen, the common ID, IMSI is sent, update PDP context request here is sending to the SGSN, and here it will inform that okay, this is the updated PDP context request, and here it will inform the SGSN that okay, the IP address of the SGSN is changed. Yes, IP address is going to be changed because for 2G we have different IP addresses, and for 3G we have, if we have different IP addresses, so uh, at the SGSN will inform that this is the updated IP address. Okay, because every interface has a different, but 2G, 3G, since GN interface is going to be the same. So in this update PDP context request, I believe what we're going to send is just the updated location information. So this is the update request. This is the updated LAC rack information, the updated tunneling ID, control and user plane, the quality of service information. Okay, the SGSN user plane and signaling address. This I believe is going to be the same. Yes, this is something that you need to inform because previously the user was attached to GSM. Okay, what you call is GRAN. So now it has updated to. So the main significant information is your UTRAN plus your service area ID and your LAC rack information. So LAC rack information changes when you go from 2G. 2G has a different LAC and 3G has a different LAC. So you update this radio access technology to update to GGSN that okay, UTRAN, I'm now currently connected to UTRAN, and my updated cell level information plus DTI is not enabled. Here DTI is not enabled. Update PDP context response from the GGSN, where it's similar to that. GGSN is going to inform you about the charging ID, its signaling address, its user plane address, ARP information, quality of service information, and request accepted, the tunneling ID, and the charging ID. And you're going to send a routing area accept message to the MSISDN informing that it has been accepted. So you come down, accept, routing area is accepted, forced to standby, not indicators, you're not going to be standby. This is the periodic routing area update timer. This is the routing area update current information. This is the PTMZ signature. This is the updated PTMZ. And that's it. And the routing area update complete. Complete message sent by MSISDN to SGSN to inform that it has been completed. I don't think we have any significant information after this. Okay. So this is okay. This is then again okay. So RNS information. This is good. This is okay. So this has been completed here, and then there is a service request. So we can cover the SRNS information from here as well in these messages. So what you will typically the SRNS request that is sent from SGSN to RNC, the old SGSN to RNC is going to look like this. So here it is asking, SGSN is asking RNC to please forward me the data forwarding items. Because if you remember, if you have downlink data and downlink data is available from MSIDN, it is not buffered in SGSN, it is buffered in RNC. So if you are moving from one RNC to another RNC, so the SGSN is going to ask the RNC, old RNC, to send me all the forwarding data that is available with you. It will be sent to the old SGSN, and then it will be sent to. Okay, so here it has sent that this is the RAB ID, this is the GTP sequence number. Okay, GTP PDU sequence number is this. So this for example, let's say sequence number 1, 2, 3, 4. So till sequence number 2728, I have sent to the MSISDN. From 2729 is something from downlink and uplink. So for downlink, sequence number 0, from sequence number 0 onwards, you need to send it. And for uplink, sequence number 2729 onwards, you need to send to you need to send to DGSN because RNC was directly communicated. So the downlink data will be sent by the SGSN to the RNC to be sent to the MSISDN, and uplink will be sent by the SGSN to GGSN to be sent to ISP side. Okay, let's see if we can find the forwarding data forwarding request in this. If we have, this is the SRNS data forwarding command. So it has given the IP address, it has given the GTP unlink ID, it has given the data forwarding command. Okay, so based on this, the RNC is going to send your data forwarding to the RNC. RNC is going to send to SGSN. And now I have moved to 2G. So this routing area update request was basically to be sent to IO release complete and complete. So now I have moved to from 3G. I moved again back to 2G. So I guess you would have a little bit of idea of how it works. Maintenance message is something that is internal. This is something that is configured with this isn't used by us engineers. This is something internally, internal communication between two nodes. Okay, I haven't found anything significant here during my troubleshooting, so we usually ignore it. If you see, I usually ignore it. It's usually in pink color, and what the first thing we do is, yes, one thing is, if there is if you find a failure somewhere, anywhere you find a failure, then you will have an EMS signaling abnormal. So if you open the EMS signaling abnormal message, then you will get a little bit of details of why the failure happened. So it is usually used in that context, that if you're observing a failure, then you open it up and it will give an error. For example, you have routing area update reject. So you will have, and you open this message, you will see the routing area update reject, and it will say that, okay, this is the cause code. So once you open up a message that is proceeding or after EMS signaling abnormal, then you see an abnormal message, you will open this up, and from here you can identify that, okay, why the routing area update got rejected. So this is an advanced level troubleshooting where we use this. Okay, so we're just covering the successful cases. In one of the future cases, we will do that. We will do the troubleshooting of session management, of mobility management, of routing area. In that okay, if failure is observed, then what do we need to do and how do we need to do? That will accompany the traces as well. And in that case, we will have a better understanding, and I will try to replicate it on my number as well if I get a chance. So then we can see in detail that, okay, what happens in this EMS signaling abnormal. Okay, so I think this is sufficient for this week. We've covered 2 hours. Going a little bit longer will I mean, there is a capacity that you can learn, and I know that you won't be able to grasp it. So I think we can conclude it for this week. Inshallah, next week we will go towards the key signaling procedure for the MME end. And I will add, because MME key signaling is usually combined. So what I'll try to do is that I will try to add up the the features as well. I will add the features as well to it, and maybe I'll add the GGSN signaling procedure as well, and then we can check that as well. Okay, so for this week, this is all for now. Okay, take care, have a nice weekend ahead, and I hope that you guys and girls got to learn something. Okay, so take care. Just stop this sharing and stop